All right, everyone. Welcome to the latest Trees Around the Globe Student Research Campaign webinar. This is webinar 67 for the campaign, even though we have lots of other webinars that we've done in collaboration with other groups, not just these monthly webinars. So we're over, I think it's about 85 or 86 campaign-related webinars specifically that we've recorded and you can view on the webinar page for the Trees Around the Globe Student Research Campaign. But today is March 19th. It's a Tuesday, 2024. It's never too early or late to start your research. Looking at research methods through repeat observations, repeat data analysis, remote sensing, and the research visions, questions, and processes of ICESat-2 and Landsat Next scientists. So that's a mouthful there. But the reason why we titled it this, it's never too early or late to start your research, is because, as many of you know, you and your students have submitted IVSS projects already, and that has all passed. And what I heard last was that this year's, the number of submissions for IVSS 2024 has been the largest ever so far. And the NASA program manager, Dr. Amy Chen, his focus is highlighting this in an upcoming some upcoming social media posts as well. So stay tuned for that. You stay tuned to the Globe website for that information. So to start off, I've been doing this lately because I like quotes, and I thought this was a great one since we're talking about some student research. May every young scientist remember and not fail to keep his eyes open for the possibility that an irritating failure of his apparatus to give consistent results may once or twice in a lifetime conceal an important discovery. This goes back to something we talk about, is like Peder Nelson mentions a lot. Is the data good? Is the data bad? Okay. So what this quote is basically saying, I should mention this is from a scientist named Patrick Blackett. He is a British physicist. He was around for a long time doing his work. He was born in 1897 and passed away the year I was born in 1974. He actually passed away a month and 2 days before I was born. So I think this is a great quote because it really focuses on the idea of when you're doing research, you can't always expect to get perfect results. You can't always expect to see perfect data, okay? And I know Peder Nelson talks often about, what's the null data, the null hypothesis? What if there's, having no data is actually data, okay? And let me give a quick, what that means is, and I see Mike Jabat's on here as well. Mike and I attended the North American Regional Meeting Workshop at the Palmyra Cove Nature Park in Palmyra, New Jersey. That would have been about 2 weeks ago, okay? But what I want to mention that is that we went outside after I gave a presentation on the ICESat-2 mission and the NASA Globe Observer trees tool. We went outside and we went to find the trees that ICESat-2 measured near Palmyra Cove Nature Park. And there were two major photons that I focused on there right along the Delaware River in New Jersey, across from the city of Philadelphia, Pennsylvania, in the United States. And one of them, the trees were gone because the United States Army Corps of Engineers was doing work there with the Delaware River. And it was right along the edge of the river. And those trees, even though last year I was there as well, working with about 100 students, taking observations of these trees, and we got observations and we got measurements from ICESat-2, but those trees are no longer there because they were taken away due to this work done by the United States Army Corps of Engineers. But then we found another one as well, so we were doing lots of really cool things. So, that data that's not there anymore, okay, it's still actually data, okay, that we know that those trees are not available anymore to observe. So today in our agenda, I'm going through the introduction to metrics now, and then I'm going to play something unusual. Our campaign team talked about something really cool if we could talk to some scientists, and I did some interviews with Dr. Sorin Popescu. He is a researcher and professor at Texas A&M University, Ecology and Conservation Biology, and he's also an ICESat-2 principal investigator, meaning that he plays a major role on the ICESat-2 science team using the specific ICESat-2 data, and what he focuses on are trees and vegetation. And then we will watch part one of the recorded interview with Dr. Bruce Cook. And I know this is near and dear to Peder Nelson's heart. Bruce is a NASA physical scientist with the Landsat Next project at the Goddard Space Flight Center in Greenbelt, Maryland, in the United States. So I created I did the interviews, and they each came out to about 16 minutes long, but I split them up into two parts, and we will listen to the first parts of each one of these interviews in a few minutes. But then we will go, I will be doing part two, the second half of the interviews at the beginning of the April webinar. And we're looking to hold the April webinar on the 23rd of April, a day after Earth Day, because Earth Day is really busy and hectic for a lot of people. So we're going to do it at the same time on the 23rd. And what's cool here is that we're going to have students and teachers come in and talk about their IVSS projects. And we have some folks on here. One of our colleagues from Folahan from Nigeria. They agreed to bring the students in to talk about this. So Folahan and the students will be discussing their research project. So stay tuned for that information coming soon. Our campaign team is actually meeting tomorrow at this time to talk about that webinar and finish planning that. So after that, we will have after the interviews, we'll have a discussion, kind of an open discussion about, what the scientists were saying and how could you apply. Are there methods that they use that you have seen, some of your students use, or have you heard any ideas from them? Because they're going to be talking a little bit about what the mission is, and then also how they came about coming up with research questions, and then taking those research questions and trying to answer them using this remotely sensed data from either ICESat-2 or what's going to happen in Landsat Next, with Landsat Next when it launches in 2030. Peder Nelson, as you know, if you've been on past webinars, which most of you have noticed that Peder mentioned Landsat Next often, because we're looking at, right now over 52 years of Landsat data. So that's an amazing amount of data to use. But then Landsat Next will be a technological marvel, and we will be able to get so much more data compared to all the other Landsat satellites that actually provide us with amazing amounts of data. And then after that, we will Peder Nelson will tidy things up with Research Road Mapping 2.0, and he will focus on looking at, he'll focus on the data, on the tools and things like that. So, and then we'll have a final Q&A and then some final thoughts, and then we'll adjourn for this webinar. So quickly, I do these metrics every time, this, and I want to draw your attention to year 6. We are really rolling with observations for year 6. We have over 17,000 measurements from almost 4,000 global sites. This is tree height, land cover, and greenings, green up and green down. And I was especially excited to see that we have a real nice uptick in the green up, green down observations, especially from the folks who are part of the European Phenology campaign, which ramped up very recently for the spring green up. So we're excited to see those numbers coming in, and the great job by Bara, Lenka, and Donna from the Globe Czech Republic, who are leading that effort, leading the European Phenology campaign. And then also draw your attention all the way down here to the bottom for the life of the campaign, which, as you know, began on the 15th of September 2018, coinciding with the launch of the ICESat-2 satellite from California, the Vandenberg Air Force Base, now called the Vandenberg Space Force Base, right on the coast of Central California. We launched a lot of rockets from there, the real big rockets, because ICESat-2, as you know, is launched on the last Delta II rocket. So a lot of rockets that get launched from there are super big. We actually have a launch facility here at NASA Wallace Flight Facility, but the largest we launch here are from Antares. They're Antares rockets, and those are the ones that we do a lot of resupply to the International Space Station from here in Wallops Island, Virginia, in the United States. All right. Before I move on to today's program specifically, I want to remind you that if you happen to be in the area of the eclipse, and I know a lot of you are from other parts of the world, the majority of you are other parts of the world, but we are holding the Globe Eclipse Challenge Clouds and Our Solar Powered Earth. This doesn't mean that you have to be in the path of totality or somewhere in the United States or Mexico. You can still do these cloud observations. It just won't really be specifically related to the eclipse, unfortunately. But you can see here, it recently began a few days ago on the 15th of March, and it runs for 1 month through the 15th of April. So that'll push us through the April 8th, 2024 date of the eclipse. And I have a link down here to the page, and I'll post that in the chat later. And then if you happen to be in the United States, this is the really cool map that has been created. And you can find this on you can just go to Globe Observer, and it's one of the rotating banners up top. You can click on the information about the globe eclipse page. But this is showing you the map of the United States and where the line of the total solar eclipse is. It's the shaded line with the circles through it, giving the estimated times it'll be at totality. But then where I am in Virginia, I'll be here at the NASA Wallops Flight Facility Visitor Center doing some activities with the Globe Observer, because with the Globe Observer, as you know, during eclipse time, an eclipse protocol pops up where we ask you to take cloud measurements, cloud observations, and air temperature observations. But we want you to do anything. If you can do some trees while you're there, and of course do land cover where you're observing from, that would be great. But this is here showing you as it runs through, part of Canada, the northeast part of Canada, runs through, all the way down through the United States, through Texas and into Mexico. So hopefully our folks in Globe, Mexico, who we've worked with a lot, and that's who our November 2023 campaign webinar was focused on them. We hope they get some out there and get some good observations, because it looks like it's running basically through the middle of the country of Mexico. All right. So with that said, I'm going to start playing a couple of these interviews. The first one is going to be, and these are all about like around 6 minutes or so long. So we'll jump from one to the other, and then after that, I'll come back out, and then we'll talk a little bit about, we'll open it up the floor for any discussion of things that you heard that you're interested in, or even things, and you can put these in the chat, even questions that you'd like me to take back to Dr. Sorin Popescu or Dr. Bruce Cook, that I can send to them. They're very quick at getting back to me. So if you have any questions about the data or their research, what they do with their research results, how they go about their research, how they form hypotheses based on the science that they research every day. So once again, Dr. Sorin Popescu, he's a great guy. I hung out with him in Mexico when I was there in November. We ate some weird food together. We just like to try. We both like to try new food, so we had some really good foods. But he is a researcher and professor at Texas A&M University Ecology and Conservation Biology Department, and also, as I mentioned before, he's an ICESat-2 principal investigator. And you can see him in the field with some university students that he works with, and in the lab. You can see here on the lab, he's working with a drone. That looks like it might be a octocopter, so it's a pretty powerful one with instrumentation on it. And then you can see here he's got some terrestrial laser scanning devices on the left side, looking at the vegetation and trees. And you'll hear something really cool, a map that he's going to come out with very soon. He has a publication where he's going to be creating one of basically the first ICESat-2 map of vegetation and tree height and trees that they've gotten from the ICESat-2 satellite. So let me go ahead and start this interview, and then we'll jump into Bruce Cook after that.
In this profile, the vegetation is dominated by shrub mopani, which is typically in the 2 to 3 meter range. And there's also some mopani and acacia trees that typically are in the 4 to 6 meter height range. Something that scientists need to understand and quantify is where carbon is being taken up and where it is already being stored. Because much of the effort related to mapping global biomass has been really focused in the tropics, where the trees are large and the biomass is high, many of these savanna and woodland ecosystems tend to get neglected or are poorly characterized in global carbon accounting efforts.
Okay, welcome everyone. My name is Brian Campbell, and I'm the lead for the Trees Around the Globe Student Research Campaign. And today we have a special guest we're going to talk to. This is Dr. Sorin Popescu, and he is a researcher and professor in an ICESat-2 mission. As you all know, all about ICESat-2, he is a principal investigator with the ICESat-2 mission at Texas A&M University, Ecology and Conservation Biology. Dr. Popescu, thank you so much for being here. Can you tell us a little bit more about yourself?
Sure. Thank you for having me over. So my name is Sorin Popescu, as Brian mentioned. I'm a professor at Texas A&M University, the Department of Ecology and Conservation Biology. And here is where I teach and pursue research in remote sensing with the focus on vegetation three-dimensional characteristics with both active and passive sensors. But the most research area is using LiDAR, three-dimensional structure measurements that we can obtain from LiDAR to assess various ecological parameters, vegetation biophysical parameters, such as dimensions, first of all, and then relate those to carbon, biomass, surface and canopy fuels, and ultimately involve remote sensing to better characterize the vegetation role in the terrestrial carbon flux.
Excellent. And I know I heard you mentioned LiDAR, and for folks, we're talking basically about measuring things from space on Earth, measuring height using lasers. And it's amazing everything you just mentioned, the information we can get from data coming in from laser pulses. So it's just really amazing to see that just, you think of a simple laser beam is actually can produce some complex data and some great results. So, and I know you work with the ICESat-2 mission. You mentioned you work with vegetation, trees, forests, things like that. And with ICESat-2, when you decided you were going to work on ICESat-2, what are some of the thought processes that popped up in your head, like visions you had about what you'd like ICESat-2 to be able to do based upon your research interests?
Yeah, very good question. So to answer the question, probably I need to go back a bit and talk about my initial involvement with LiDAR. So with ICESat-2, I've been involved since 2014 as a member of the science definition team, which later evolved after launch into the science team. But my involvement with LiDAR starts earlier than that. Actually, in 1998, when I participated in a NASA graduate student summer program at Goddard. And that's when I got the first hands-on experience with the LiDAR data set and airborne LiDAR data that fascinated me for the first time to see trees in a digital 3D model. And that's when my vision sort of emerged about the potential of tree measurements, vegetation measurements.
Brian, I think, Brian, this is Peter. I think the sound went out. We can't hear. We can see the video, but we can't hear the volume, the audio.
For some reason, it automatically muted me. Can you hear me now, Peter?
Yes.
Let me go back. Yeah, I went back in and it said muted. Let me go back. Sorry about that. But that's Zoom for you. I'm going to start it, Peter. Let me know that you hear it.
Improved on the LiDAR
Yes.
technology. It's a photon
Cool.
counting LiDAR from space. So it's a pretty amazing technology to think about being able to count photons of the laser light that get returned to the satellite. It has a much better footprint size and sampling design for vegetation studies. And I also got to be at the launch, which was a very exciting time. But the excitement was not over with just the launch. Then in 2019, we got to visualize the first vegetation profile from ICESat-2, and the on-orbit data really looked fantastic. We were a bit nervous to see the first data from space, photon counting LiDAR, but it looked great. And to these days, it proves to be extremely useful. I'm happy to mention that we just completed the first vegetation canopy height mapping product with ICESat-2 data that covers the continental US at Landsat-like spatial resolution. So that was the initial vision, and here we are. We have LiDAR from space that keeps improving, data keeps accumulating. It's not only ICESat, it's JEDI as well. It's really, I think, an exciting moment to do vegetation science with LiDAR from space.
All right, that's the first part of Dr. Sorin Popescu's interview. I'm going to, he also mentioned JEDI, and we have mentioned JEDI before, and if you've been trying to look up recent data and haven't found any, the reason why is kind of the end of last year, the JEDI mission, the astronauts on board the space station had to just take JEDI and put it in storage because a group needed to put another instrument at that location on the International Space Station. But rest assured, it will be back up and operating later this year. I don't know the exact dates. I'm thinking they mentioned the fall of 2024, and that because the other one will be done with its observations, but JEDI will be reinstalled back on the International Space Station, thus providing lots of great tree height observations along those mid-latitudes with the orbit of the space station between 56 degrees north and 56 degrees south latitude. But I want to jump right into Dr. Bruce Cook, because when you're watching this and what you heard from Dr. Popescu, or when you're watching Dr. Bruce Cook, I want you to think about what are some of the things that some of the similarities in their their research methods or thought processes or visions that they saw when they were trying to figure out what they want the satellite that they're working on, what they want it to do, especially in the sense of their scientific research and what they want what the satellite data wants to what it says about what's going on with our planet in its response to a changing climate. So once again, this one will be Dr. Bruce Cook. He's a NASA physical scientist at the NASA Goddard Space Flight Center in Maryland, in the United States. It's in Greenbelt, Maryland, in the USA. And he is the lead scientist for the Landsat Next project, which, as I mentioned earlier, Peder Nelson mentions that frequently because Peter works a lot with the Landsat data. And I know we'll talk about that later because he's super excited about Landsat Next. Unfortunately, it won't launch until 2030, but that's a lot of time to get, all their, quote, ducks in a row, unquote, to really showcase what NASA, what satellites can do, the data they can provide us. So it's going to be along the same type of interview questions because I wanted to create that, that collaborative effect of, what the scientists, what the PhD scientists do with these missions and what they want their data, what they're hoping their data can tell them. So let me go ahead and play this one as well. This is part one with Dr. Bruce Cook.
We live on this planet Earth. We all know that we want to leave this planet for our children. We know the importance of sustainability, and I think that's what Landsat's all about. It's about helping us manage the planet that we live on for the long term. And that's why it's there, and that's why it continues to be here, and we expect it to be there for the next generation as well.
Hello, everyone, and welcome to a really cool interview we're going to have with Dr. Bruce Cook, who is a NASA physical scientist. He is the project scientist for the Landsat Next mission, which you have heard of at several of our Trees Around the Globe student research campaign webinars over the last several years. And Bruce is based at the NASA Goddard Space Flight Center. Good morning, Bruce.
Morning, Brian.
All right, can you tell us just a little bit more than what I mentioned about you, and then what you do with NASA?
Yeah, I'm a research scientist here at NASA Goddard's Space Flight Center, and I'm also a project scientist. And I'm working on the 10th in a series of satellites that's been tracking the changes on the Earth's land surface since 1972. So that's more than 50 years now that NASA has been developing and launching satellites for the explicit purpose of improving resource management and for protecting Earth's inhabitants here on Earth. A lot of people aren't aware that that's one of NASA's job, is actually turning the telescopes around and actually focusing here on Earth's resources, and that's what one of my responsibilities is.
Excellent. Yeah, that's one thing that we run into a lot at NASA, don't we? Where, when we talk about NASA, we think of, looking at the planets. We think of looking deep into space. We also think about, astronauts and space shuttles. But, we do such amazing work in Earth sciences at NASA. We do everything. And so thank you for joining us today for this short interview. But yeah, that's great. We've been really talking about Landsat a lot in the campaign because one of the major observations that we focus on for the student research is looking at land cover and how that changes over time, whether it be 5 years, 10 years, 20 years, 100 years. We're really looking at that, and and with that 50 plus years of data from the Landsat series of satellite, and with Landsat Next to come very soon in around 2030. We're going to have such an amazing database of Earth science data that's really going to see how things on our planet have changed over time, how we can use that data to protect our planet, as you mentioned, and then really see how our planet's responding to a changing climate, literally every day. So a couple questions for you, since this is a Trees Around the Globe student research campaign. Let's talk a little bit about research. And, when students, as part of the campaign, they often have some difficulty figuring out what they want to research and how they want to do it. And I know with scientists such as yourself, when you look at what you want to do, you come up with some science questions, you come up with visions initially that help guide you to what you want a satellite to do and how it can benefit everybody, using that science at some point. So when you started to plan, with your colleagues, Landsat Next, what were some of the initial things you were thinking about, like visions that you were having of what you want the satellite to do, what you wanted to tell us?
Well, when you inherit a 50-year-old program, the first thing you want to do is you make sure you don't break it, right? That's the first thing you do. But with a 50-year-old program too, is you always want to inject new technology into something like that. It's the same thing. You go to the store and you want to buy a new iPhone or a new phone. You want to get the latest technology, but you also want to make sure that you have continuity with the past too. That you want to have backward continuity with the past, so that you have this continuation of your time series of the previous measurements. So you have this backward compatibility with your existing measurement record. That may be continuity with the bands, the spectral bands. It may be continuity with the measurements, that you're having the same coverage, the global coverage. You want to make sure that you're getting that same comparison so that you can have this, what we call the ability to compare measurements not only from place to place on the globe, so that they're comparable, but also to be able to go back into time. We often compare Landsat as being able to step into a time machine, that you can go back into time and have those comparable measurements, both in space and in time. I think all of us know if you're taking a picture of some place with your phone or with my phone, we'll have two different images and they're not necessarily comparable because they're from two different cameras. But Landsat's cameras, even though this, as I mentioned, this is the 10th satellite, they're very well calibrated to one another such that we have comparable images, comparable data sets to compare the data from one imager, one instrument to the next over the long time series. And that's a unique aspect of the Landsat series of measurements, is that they can be compared over the time, over the length of this 50-year history.
That's interesting because that falls along the lines of one of the things that we asked the students to do and the educators to do when they're out taking observations. We asked them to do repeat observations in the same location so we can compare those. Granted, it might not be on the same device each time, but so they can compare those from each time they take a picture, whether it's, a week later or a year later or 2 years later, so they can compare those images. And I also like what you mentioned about continuity of the data, because we don't want those nasty data gaps that we hear about. We want to be able to continue the data, throughout time. So that's great. So with your, thank you for that. And with your vision, and what you wanted it to do, with the continuity and being able to compare this, this imagery in the same location over a long period of time, you had to come up with some research questions, specific ones over time, that you really wanted to tie this vision to what you wanted Landsat to do. So are there any, how did you come up with any research questions? Did you do it as a team, or did you, individuals came together at some point?
Yeah, this is where we really poked on the users themselves. It wasn't me making the decisions, and saying, hey, this is what we should do. This is where we went out to the community and we said, and the community is quite large. You can imagine over a 50-year period, there's a lot of people that use Landsat data. It's averaged at 40,000 people are using per week, are downloading data and using Landsat data. There's some 1 million articles. If you do a Google, scholar search, you can find 1 million articles will pop up on your search. It's amazing the amount of people that have been using Landsat data and that comprise the community. So we had several surveys that were conducted of that community. We had a lot of user forums that were conducted. There were a number of papers, white papers that were drafted. We had a lot of informational meetings with subject matter experts and such. And we polled the community to see what their needs were. And these needs evolve over time. They are not stagnant. And so there were three needs that popped up. One was the increased need for higher revisit frequency. Right now, a single mission was only revisiting the same spot on the globe every 16 days. And so we're going to be improving that by about, we're going to increase that to every 6 days.
Wow.
And then also the spatial resolution was at 30 meters, and that's going to be improved to 10 to 20 meters. So that's going to be improved. And then spectral information, we had 11 bands before, and now that's going to increase to 26 bands. So just about everything is going to be improved by about two to three times improvement. Wow. And that was based on the user community, not based on my decisions or anything like that, but based on the science needs of the community. And again, that changes all the time.
Sure.
You can imagine the needs back in the 1970s when fossil fuels were all the rage. People were lining up at the pumps and fossil fuels were what we needed. Now that's not necessarily the case. Fossil fuels are kind of on the outs, and maybe we're looking at more renewable fuels. And maybe, you know, sustainable fuels are more of our, you know, our need. So things change, you know, over time, and needs change. Water supplies are more important for a population that has doubled since 1970. When the first Landsat was launched, we only had a population of about 4 billion people on Earth, and now we have 8 billion people. So demands on our resources have increased quite a bit too. So needs change over time, and we'd be able to respond to that.
All right. So now that you saw a little bit or heard a little bit from Dr. Bruce Cook and Dr. Sorin Popescu, what are some things, I want to open this as informal discussion. What are some of the things that you heard that really resounded with you, whether it be as you know, as an educator or a scientist, or one who works with students and their research projects? What are some of the things that you heard there that really resonated with you? And feel free to unmute, or you know, raise your hand, unmute that, but then also you know, any ideas that you may take back to the students that you heard about. So let me go ahead and open that up, and feel free. You can use the chat, or you can open it up and just say something if you like.
Hi, Brent. This is Peter. I have a question. Either you or Peder Nelson can answer this. I understand what he means when he says, you know, there's better resolution. But what can we get when we see more bands? He mentioned, I think he said like from 11 to 20 bands. What does that mean for science? What kind of research can they do with that? How does that improve understanding our planet?
I'm going to let Peter answer that because he has definitely more knowledge on the bands and everything than I do. So, Peter.
Yeah, well, that's a perfect question, Peter. You know, to kind of lead into how one of the things that these scientists didn't really mention, they kind of alluded to it, was, you know, and Dr. Sorin alluded to this too. He started looking at satellite measurements back in 1999, and similar to what Dr. Bruce Cook mentioned, you know, they started looking at the Earth from space 50 years ago. And so, you know, each time, one of the things that happens is you learn what you can see and you learn what you can't see. And there's things that happen over that lifespan of making measurements that you realize, like, oh my gosh, wouldn't it be great if we could get rid of the cirrus clouds that are influencing our measurements in the blue light, because of just what they are. We can't remove them like we can, say, cumulus clouds. They're not as easy to see. And so it's this learning, and actual literal failure of being able to sometimes measure what we want. The instrument isn't detailed enough. And so one of the jobs of both of these two scientists is actually describing that error, the uncertainty around that measurement. And Brian and I have really highlighted this because that's why they've decided, or the community has asked for, more spectral measurements, or greater spatial resolution, is because every instrument has a limitation to it. And so through the last 9 iterations of Landsat, really 8, but you know, from all those measurements, we've learned some of those limitations. And so when you go back and you look at the older instruments, you might see that they're not as you know, good at seeing things on the ground. They're maybe a little bit more blurry, and part of that was the technology of the time. And we now have better technology. And so we're able to get better at quantifying and describing our measurements, which help us to make better measurements. And that's really what it comes down to, Peter, is, you know, when we look at why the community is asking for a new satellite, right, to just continue making these observations. one of the things is we have better batteries, so we can actually have 26 bands, right? In 1984, we didn't have the technology to be able to make those that number of observations. And so when we go down, I mean, this is kind of what we're talking about in terms of being able to make more discrete measurements that actually allow us to get at some of the questions of today, like what Dr. Bruce Cook was talking about. So, this does lead into, the questions of the past sometimes get answered, right? Where are the trees? Well, once we find that answer to that question, we might need to come up with new sensors to start looking at how those trees are actually growing and how they're using the water, and move beyond just that question of where are things located, but get into the quality of them, like the leaf. How well are they photosynthesizing? Which I know is a big issue for us here in our part of the world, and drought. You can actually get into various questions about adding more thermal measurements, so we can actually see things like fires and volcanoes better. We can make that surface temperature measurement, which again is one of those newer questions that here in the GLOBE campaign or in the GLOBE world, we talk a lot about surface temperature. And so, that's one of those newer questions that we've found out our current sensors can do a good job, but through research in the lab and through some of that engineering design, we're figuring out that we need to have our better measurements and more precise measurements. So, as we go down this, I do think that it's really important to go down. And I wanted to highlight this graphic because it really highlights what are some of those questions that scientists are looking to answer in the future. Water quality questions, plant health questions, the water quality and this interaction between what's happening on the land and what's happening in the water, along with a lot of other vegetation related questions. So, we've learned from the past, and I think that's the big answer to that question, Peter, is we've learned what we can't see and what we want to see, and luckily we have engineers who come in and help us figure out how to actually make better measurements, be able to better describe what's happening here on planet Earth. So great question, Peter. And obviously you sent me down a rabbit hole for 5 minutes.
Just the chart you're showing me, I can't help but think of Landsat Next as like the Swiss Army knife of satellites with all it can do.
Yeah, and that's exactly what it's getting asked to do. I think this is a really important, characteristic, is that it's not only supposed to keep making those same measurements over time, that it has been for 50 years, and keep those measurements going, like Dr. Cook really highlighted. That that consistency is really, really important. And but what we've also been able to really get at is understanding what some of the sensors that have been put up in orbit have been collecting, and integrating that together so that we're not having to have 4 different satellites measuring the same thing. We can actually have it all on the same satellite at the same time, making the same kind of measurements. And that works for a lot of different people and a lot of different questions, which is something that the GLOBE program supports with the 50 different protocols. And what I really want to go back to is that when we look at the number of questions that can be asked in the same place, this is the same thing that can happen over, with our GLOBE protocols, is in fact, if you make your land cover measurements, you're telling us whether there's water there or not, and whether we can do the hydrology protocols. You're giving us more information about that plant health, and even what type of plant is there. Is it a tree or is it grass? And so, you know, these are really kind of important characteristics as we go into new opportunities. And that's really what we wanted to move towards is, you know, this sensor hasn't been built yet, right? And I think this is an important characteristic of NASA science, right? Is you don't just put something up into space. In fact, one of the things that is going to be happening and has been happening over the last couple of years, and that our students can take part in, is testing out, you know, what are the measurements that come from an instrument that can make measurements across all of these spectral responses. And this is where we've brought up Stella in the past. We've even brought up Globe Observer, and what we're doing here with our blue, green, and red ground photos. We want to simulate what this Landsat Next satellite will actually record. Right now, you know, they've done some lab measurements, but we don't really know. And this is a great opportunity for students to actually simulate, go out and make measurements, so that when this satellite actually goes into space, we can better understand and, you know, characterize what's happening between the satellite's measurements up in space, that atmosphere, and also what is happening on the ground, right? And the cool thing is, you know, this satellite will be going up in 5 years from now. And so there's a lot of time right now, while this is still in development here on Earth, to start thinking about exactly that question, Peter. Well, what are we going to get when we start making these measurements in these wavelengths, right? And this is something that we've talked a lot about. So, you know, I'll go back up to this piece of things. This is, you know, this spectral science is what we do here in our campaign, and so, you know, with that, I think it's just really important to recognize that these are the things that will be coming in the future, and that students can prepare for right now with their surface measurements, with some of the spectral measurements that we've talked about. And even the fact that trees are going to continue growing over the next 5 years, right? And so we should just expect that there's going to be some wonderful opportunities for change in describing spectrally what is happening in these locations. Okay, I went off on another tangent there, but I really, this is the science that we're doing. And so I think it's really kind of neat to start thinking about, you know, this, as well as, you know, I think, you know, Peter, this is one of those big pieces, is Landsat isn't the only satellite up there, right? And so we have all of these satellites that are making observations from space. And I think it's just a recognition that by bringing all of this together, we're able to get deeper understanding of the planet Earth and what's actually happening out there. And I think, you know, to me, that is exactly what all of our learning activities are about, right? So, so to me, you know, one of the things is, like, wouldn't it be incredible if people have actually been consistent in the same way the satellites have been for the last 10 years, mapping their land cover, or you know, doing some of these different globe activities. And I think that's, you know, the take home piece that Peter and I want to talk about is, you know, this evolving piece of inheriting a program is what Globe is all about. And so, you know, the students that were here in 2014 have probably moved on and are at a different phase in their career, but their data, their measurements are still really valuable, even if they're not, you know, made with the same instruments that we would use today, or be done in the same way, right? And this is the tie back to the technology at the time, and really needing to be able to describe how you made that measurement and the instrument that you used around that. And so, you know, we're trying to keep it consistent, just like Dr. Bruce Cook mentioned. you know, how you need that in a program that is looking at climate or across long periods of time. But there's this opportunity to engineer new sensors to help us solve some of these problems that are highlighted in our activities, and to think about and to be part of that engineering aspect and the science to help us to understand not only what we've been doing here in the GLOBE program for almost 30 years, but also get prepared for the data that will be coming down that you know, we don't know, we didn't anticipate necessarily that this is what would be coming down to us from space, right? But this allows us to actually you know, prepare ourselves for future missions, future satellites, and to me, that's the important thing, that as trees grow, we're going to be able to better understand and describe their location and what's happening around them. And therefore, why be able to answer that question that Brian keeps pestering us about at the beginning of this? You know, why are those trees the height that they are in that location?
Thanks, Peter. There are a couple of questions in the chat. I think Brian took care of them. But one I would like to say, and I struggle with this myself, when I get energetic and I start talking about something passionate, I tend to speed up. And I realize some of our guests are from other countries where English is their second language. So maybe if you can slow down just a little bit, because I think some of them may have a difficult time keeping up with our energy and our pace sometimes.
All right. Yeah. If you want to take a look at those questions, let me just re-answer those so people don't, in case people don't see the chat. Anna asked, where is it? Yes, she said, could water quality analysis be done? Sorry, that's not where I want to go. The one before that. Sorry. It is, do the watercolor bands detect changes in chlorophyll only or also chemical components? And I did mention that, yes, there will be, you can see there's going to be new visible bands on Landsat Next that will help scientists and resource managers manage water quality by identifying chlorophyll or dissolved organic material in the water, as well as HABs, harmful algal blooms. So yes. And then also a question from Kumanowicz, how can a satellite determine plant health? And I directed them to check out the EcoStress mission. And if you go to our webinar page, page on the campaign, and I don't remember exactly what, that was several years ago, but we had a presentation from a JPL scientist all about the EcoStress mission. So you can check that out. I put the link right there to EcoStress. So that really looks at the health of the plants and vegetation on the planet by basically taking their temperature. So it's a really cool thing to see. And those of you who have to run to other meetings, that is perfectly fine. As you know, we always tend to go over an hour to like an hour and a half. But as you know, this is being recorded. So you will be able to watch this recording very soon once I get it up there. And that's usually within a day or so until Zoom gets me the recording, and then I can do some processing with it as well. Peder Nelson, do you want to mention that link you just put on there, what they can see there as well?
Yeah, so I think it's really important to take advantage of the materials for the tour of the electromagnetic spectrum that I shared in the chat here. And that goes through and provides that foundation of how do we measure plant greenness using sunlight or doing this remote sensing? What is it that we're talking about here? So I, as an instructor, really love that particular resource with that. And to me, that sets up, again, one of the things we've talked about in our webinars in the past, which is this particular set of, I guess, instruments and sensors that allow you to, again, simulate or actually make spectral measurements, like we were talking about there. This is that NASA science. And And so, feel free to look this over. I will be doing a webinar on this and as well in April 15th, actually. And to me, this is a really wonderful way of making this connection. Okay, so this is a way of putting that satellite measurement into the hands of students and allowing them to see what is that fingerprint, or what is the spectral curve of different materials. So I wanted to highlight this, especially because it allows us to look at that Landsat Next mission, or any of these satellite missions that are coming up in the future or happening right now, and be able to make similar measurements. Okay, and so this is something that we've highlighted in the past, but I wanted to highlight again, because we've been talking about what are these measurements that we're making, and I think it's just really useful to go back and really use that tour of the electromagnetic spectrum to be able to better describe what the heck is happening with all of these wires and things like that. So yeah, that was the connection there that I wanted to make, because it helps us to understand what all of these things mean, really. And to me, that's a lot of it is being able to understand these measurements is the key to understanding NASA science and making that connection. And it's a great question about being able to get the materials and everything to be able to 3D print and be able to make this instrument. But feel free to reach out to Brian. I think Brian or myself or Peter, and we'll do a little looking to see what might be possible for different places. Sensors and technology can be both fun, but also, very challenging sometimes outside of the United States. So, Anna, great question about that. But, and so we wanted to really, kind of get everybody here thinking about that future, how, scientists are using instruments like this here in the lab to simulate and understand what they're going to get from that future mission. And why should they actually measure what they're going to measure, right? Because we want to make it really useful to everybody. And to me, again, this is one of those big pieces of what the GLOBE program has been doing. And I want to just kind of quickly, show people that, I think it's really important to recognize that, the data that's being collected here is being stored and is available to us all in the way that both scientists describe to us. And so, it's really important to recognize that, these repeat measurements, really are useful when they're stored in a location like this, and then starting to be combined together with the satellite data. And so we want to really support people going out and doing that. And because it is this long-term effort that we're going for. And I think this is kind of the really important piece is for us to not only contribute to the database, but to look at how what instruments did we use to make those measurements, and importantly, how has the technology changed over time? And the tree height measurements are one that I think is really, really important to think about. What, as Brian has highlighted, what is the difference in making a measurement with a clinometer versus making that measurement with a smartphone or a device like that? Is there a difference there? And that's very similar to what both of our speakers talked about today. When they first started making measurements back in 1999, using these lasers in space, they had a certain resolution, and they had a certain instrumentation to them. It's different now, and so we want to be thinking about what is going to be the instruments of the future. How do we use them? And so I think, to me, that's just a really important step in why we are bringing up the methods that we are with the open science, with the Globe database here, and really trying to think about not only today's measurement, but really bring it into the future and what we can do. So I wanted to highlight this piece of the science that we're trying to do together. And I think it's really important to recognize that we've inherited the GLOW program, just like Dr. Bruce Cook inherited the Landsat program. And it's our time to make our measurements and to put them into the database so that they can be useful. And we want to encourage you to explore those past observations that have come in and think about those instruments that you were even using back 5-10 years ago or so in the GLOBE program to make those early measurements. And think about how that might have changed and how those numbers might be changing too, because you're using a different instrument. So that I wanted to really kind of stress, this piece of the fun part of science, that it's not just about going out and measuring those trees, but it is also important to think about how we're measuring those trees, and that those ways are changing over time. So with that, Brian, I'll hand it back to you and let you continue on with our webinar.
All right. Thank you, Peter. Does anyone else have any other things they want to bring up based upon what Peter was talking about, as well as Dr. Bruce Cook and Dr. Sorin Popescu? Any final thoughts? And I know several people had to leave for other meetings. So our idea for this webinar was to start off talking a little bit more about the importance of the research from not just the common perspective, but one that and I should say not common across the board, but common thought processes and visions that scientists have. And our next generation of scientists are the students who a lot of you are working with, and perfecting research techniques is how you're able to really understand the data and really figure out what you're looking at, what the data means, what it means in the real world, or real world applicability. That's why all of these satellite missions have application programs, because the data can be applied to multiple things going on the planet, right? As Peter mentioned, we're looking at over 50 years of Landsat data. We're looking at data observations from the GLOBE program, closing in, I guess, is around 300 million observations in almost 30 years is coming up in a couple of years. So actually like next year maybe will be 30 years. So it's just an amazing amount of data. But the research really, when this research is being done, we have all this data, but we have to understand what this data means, and we can look at it from the past, how it compares to the present, and everything in between. And we know that's a daunting task on our side of things. On the science research side of things, when you talk about, like Dr. Popescu was talking about the ICESat-2 vegetation data, there are literally billions and billions, several hundred billion data points from ICESat-2 just looking at trees and vegetation. That's a mind-blowing amount of data to look at. And then there's also the older data that he was talking about from ICESat-1. He was talking about JEDI data. And this is what scientists, they realize that there's all this data out there, so they really focus on specific questions that they can then pull, and specific areas that they can pull this data from to look at. And one thing I want to mention too is, I kind of alluded it to in the beginning, is next month on April 23rd at 1 p.m. Eastern, same as today, we will be featuring not only the part twos of each one of these scientist interview videos, but also we will have several. And right now I have, I think it's 4 or 5 student groups and teachers who are going to come in and present from different parts of the world. We have, some from South America, some from Asia, some from Africa, the region. So we're going to have a great webinar, and some of them may be recorded, and we might be showing the recordings because it's going to be a really bad hour for them to present live. But we're excited that that they'd be willing to do this. And I should also mention that these student presentations and/or teacher presentations that are going to be part of next month's webinar, these were all from projects submitted to the 2024 IVSS. So, this is great, and we're super excited that they're willing to do this. As I mentioned, we have a couple of folks on here that are being part of that. Sajana Zaraha from Croatia, part of it, as well as Adeyemo Folahan from Nigeria will also be presenting as well with the students. So we're super excited that this is going to happen next month, because we haven't had a lot of student presentations this year in year 6 yet, because we were waiting until after the IVSS was submitted, because we didn't want to ask prior to that, because they were in the middle of their research and we didn't want to have them do this before submitting the research. So, and those of you who those teachers out here who work with students, good luck on the judging of the IVSS 2024 proposals. That is happening very soon, and I believe everything gets announced on Earth Day, April 22nd of April. That I believe is a Monday this year, 2024. So stay tuned for that. I'm sure you'll see it on the Globe website and in the Globe newsletter about the all the video, and I guess the drawings for some of the winners for the IVSS. So, stay tuned to that. With all that said, any last minute words or thoughts, ideas, comments, concerns for any of us on the campaign team, Peder and me? Or does anybody else have any other things they want to talk about? And yes, thank you, Peder. Peder just shared the Landsat Next mission page focusing on the spectral bands. So thank you for putting that up. Peter Falcon, any last words? And then we'll pass it over to Peder Nelson for any last words and to finish it off.
No, other than it's always great to have people come over and join us. So we're happy that you guys all join us. So yeah, that would be it.
Well, with that, Peder, I'll encourage everybody to go out and do some remote sensing using that Globe Observer mobile app that you have. And I know many of us are starting to see a green up vegetation, green up happening around us in the Northern Hemisphere. And those of you in the Southern Hemisphere might be starting to see a transition as well. And so, right now, I know that's the big thing that the satellites are seeing. And so just like Peder started off and mentioned, he's going to be seeing a super bloom, and we hope to continue to see those ground photos and measurements coming in as we get ready for, summer activities or winter activities, coming up later in the year. So, keep up that remote sensing that you're doing out there, and we look forward to further conversations with you.
All right. Thank you, Peder. There's one last thing I want to mention. I'm going to share my screen really quickly here that are related to the upcoming Globe Observer Connect event that's happening on Thursday. Some of you may have been a part of that before, but I'm going to show that now. This is all about basically it ties into the eclipse coming on the 8th of April. But this is Globe Observer Connect. This is at 8 p.m. Eastern Time this Thursday, the 21st of March. And the featured speakers will be Marilei Colon Robles, she's a Globe Clouds project scientist at NASA Langley Research Center in Virginia. And also Ashley Attore, she's a scientist also at NASA Langley. So they'll be talking about doing cloud observations during the eclipse and any other cloud information that you may want to discuss. But I'll pop this in the chat then, so you can see this to check it out, because there is a registration page here as well. So I'm going to, let me stop sharing, and I'm going to pop this back in here. But I wanted to mention this. You can also see this information if you follow us on the Globe program on Facebook and or X, formerly Twitter. We have some things up related to these events, to the Globe Observer Connect event. But that is this Thursday.
Right. Something else I wanted to add, now that I think about it, is in case you haven't noticed with your Globe Observer app, there are now badges. So you can go out and make your tree measurements, your land cover measurements, and you can start earning badges on your app the more measurements you do. So we want to encourage you to go out there and make those measurements, get as many badges as you can, and show them off to your friends there.
Well, at least continuous streaks. You've been getting badges the whole time in terms of what you learned, but I noticed that as well, Peter. And I'll just kind of put a marker out there. I've had my longest streak apparently was 24. So right now it's at 0, but let's see. We'll check in with everybody to see how this update in the app might have affected their streaks, and whether anybody is longer than 24. I don't know what you guys have, but that's what showed up on mine.
I think that's a challenge, that you have to try to beat Peter's 24-day streak of observations.
Exactly.
Yeah, we may need a dunk tank if you can beat that with Peter on there.
Exactly. But hopefully this will help with those repeat measurements, which again was kind of our big focus for today. So take a look at that piece in the Globe Observer app, and we do look forward to hearing some feedback and make sure that everything's still working well within the app itself, that nothing else broke. So be part of that engagement, young engineering and early adopter program, and give us that feedback. And make sure that things are still working.
And with the app, I will also mention that it's planned. Those of you who are going to be able to do the eclipse protocol will be available, I believe, on Thursday. It'll be on there. So if you go in on Thursday and it asks if you want to do an update, please do the update, because that will bring up the eclipse protocol on Globe Observer. So that will be available. And that's as of a discussion I had yesterday. It's in staging right now. Protocol's in staging, so it will be available on Thursday. I don't know exactly what time, but keep checking Thursday if you're interested. So, which I hope all of you are, but I know some of you will not be in the path of the eclipse. So, where I am at NASA Wallops, I'll be doing an event at the Visitor Center, and it will be about 81.4% partial. So it'll be pretty good. And we're actually launching 3 rockets here before, during, and after the eclipse, 45-minute intervals. And they're going to be just measuring basically atmospheric conditions during the eclipse, before, during, and after the eclipse. And that's a different group here at the Wallops Flight Facility that is doing that. So lots of good things going on. So thank you, everyone, if you want to look up that, it's called APEP, A-P-E-P. Just type in NASA rocket APEP, A-P-E-P, and you will be able to read more about that. So thank you, everyone, and stay tuned for the email coming out that the recording is available for this webinar. And then also you will see an invitation in the next few days for the April 23rd webinar. So thank you all so much for being here.